Welcome to 3.3 side, 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 and side angle side congruence. Now in the last lesson we learned that to show that two triangles are congruent, you had to show that all the sides were congruent and all the angles. Well, there's actually some shortcuts we can use to prove that two triangles are congruent, and we're going to learn about those here. So read along with me. If two triangles are congruent, it means that all corresponding angle pairs and all corresponding sides are congruent. Alright, so all the sides and all angles are congruent. However, in order to be sure that the two triangles are congruent, you do not need to know that all the angle pairs and sides are congruent. You could actually use some shortcuts, and today we're going to learn two shortcuts. The first one is called side, side, side congruence. If you look here, we have two triangles, and we know that three of the sides are congruent. Alright, we see that the first we have AB is congruent to DE. We have BC is congruent to EF, and we have AC is congruent to DF. So we have three congruent sides here, and since both triangles have three sides that are congruent, we know these two triangles are congruent. So I would say that what am I writing with there? I would say that ABC, triangle ABC, is congruent to triangle DEF. And all I need to know was that there's three congruent sides. Alright, if there's three congruent sides, then the triangles are congruent. Let's try this. So we're going to determine if the following triangles are congruent. Alright, so let's look at our two triangles here. Well, in our first one, alright, and I like using a highlighter for this lesson, we'll see that YZ is congruent to EF. So we have one congruent side. We see that ZX is congruent to DE. So that's two congruent sides. And then we see that YX is congruent to DF. So since I have three congruent sides, I know that these two triangles are congruent. So triangle ZYX is congruent to triangle EFD because of side, side, side. And that basically is saying that there's three congruent sides. So you see, three congruent sides, I know the triangles are congruent. Well, let's look at our next one. In this case, I know that LM is congruent to KH because they're marked, and I know that LN is congruent to HG because they're marked. But I'm missing a side here, alright? And since I know that these two sides aren't congruent because it doesn't have the marks, these are not congruent. Alright? And that's actually all, because all sides aren't congruent. You need to have all sides congruent here. And since only two of them were, we didn't have enough information there. Only two of them were congruent. Alright, so now in the last part we just had to determine if the two were congruent. Now we're actually going to prove it. Well, where are you going there, buddy? Move on down. Let's go. Come on. Okay, here we go. Alright, so to prove that two triangles are congruent, you have to write that there's three congruent sides. You actually have to write out your proofs. Alright? First you write your evidence and then you write your conclusion. Alright, so now we're actually proving. This is very different. So to prove, we're going to list out our evidence, and that's that the three sides are congruent. So let's start with our first side. Our first side is that ZY is congruent to MN. And we know that because they're marked. So ZY is congruent to MN. That's our first piece of evidence. Our second piece is that ZX is congruent to ON. So ZX is congruent to ON. And then finally our third piece of evidence is that YX is congruent to ON. So YX is congruent to ON. And because I have three congruent sides here, I now can read the conclusion that triangle, oh, why is this lagging so bad? Let's try that again. We know that triangle XYZ is congruent. XYZ is congruent to MNO. Okay, and why? Because of side, side, side. Let's prove that these two triangles are congruent. Once again, it's the same exact thing. You just have to show that there's three congruent sides here and write out your evidence. So we have our evidence and our conclusion. So our evidence is, well, we know AF is congruent to PT. So we're just going to write that out. AF is congruent to PT. Our second piece of evidence is that FS is congruent to HT. So FS is congruent to HT. And our third piece of evidence is that AS is congruent to PH. So AS is congruent to PH. Okay? So now that we have three pieces of information, these are all sides, I know that triangle AFS is congruent to triangle PTH. And that's why? Because of side, side, side congruence. Alright, so you need your evidence and then you could read your conclusion. Alright, the other shortcut we're going to use is called side, angle, side congruence. Alright, so side, side, side is one shortcut. Side, angle, side is our second shortcut. If two triangles have two pairs of congruent sides, such as what we see here, where we have this and this side are congruent, and this side are congruent, and the included angle in one triangle is congruent to the included angle in the other triangle, which we see right here, then the triangles are congruent. Well, let me make this a little easier for you guys, okay? How to determine using side, angle, side. Alright? There must be two congruent sides with the angle in the middle of those sides. Alright? The angle must be in the middle. The way you can determine that is by using a highlighter. That's really going to help you, okay? So if you look here, we're going to highlight our congruent sides in both of these. Alright? And then you're going to write over your congruent angle. And your congruent angle is right over here. Alright? Is this angle in between those two sides? Is this in the middle of those two sides? Yes, it's right in the middle. So since there's two congruent sides and a congruent angle that's in the middle of the two sides, then we know that these two triangles are congruent because of side, angle, side. Let's see if it works here. Alright, determine if the following triangles are congruent. Well, we have ABC and DEF, and if you look here, I'm going to take out my trusty highlighter. Let's grab that highlighter out and let's highlight our congruent sides. And this CB is congruent to FE. Alright, so we have two congruent sides. Now let's mark our angle. Alright, let's take out our blue. And you have this angle right over here in the middle, right? And since you have two congruent sides and the angle is in the middle of those two sides, we know that these two triangles are congruent because of side, angle, side. So I know that triangle ACB is congruent to triangle DFE because of side, angle, side congruence. Well, let's try this again. Alright? Well, in this case, I know that NM is congruent to TP, and I know NL is congruent to TO. Now, this angle is over here, and this angle is over here. Now, if you look here, this angle is in the middle of those two angles. See how it's in the middle? You have the side, side, and this is in the middle. This angle isn't in the middle, right? It's up top. This is not in the middle. Not in the middle. And because it's not in the middle, I can't use side, angle, side congruence. This is actually side, side angle. Alright, it has to be in the middle. So these are just not congruent. Alright, and they're just not congruent. I don't even want to put because. It's just not congruent. The angle has to be in between the two sides. So once again, we're going to prove the triangles are congruent. You just collect your evidence and then write your conclusion. So in our first one, we see that CB is congruent to MO, and we're just proving right now. We're writing our evidence. So CB is congruent to MO. Okay. I have angle B is congruent to angle O. So angle B is congruent to angle O. And finally, AB is congruent to ON. AB is congruent to ON. All right. Well, since I have a side angle side and I have all the evidence to prove it, I know that triangle ABC is congruent to triangle MON because of side angle side congruence. Let's try it one more time. In this case, we have AB is congruent to EF. All right. We have angle B is congruent to angle E. Angle B is congruent to angle E. And then finally, we have BC is congruent to DE. And once again, I know that these two triangles are congruent because of side angle side. The angle is in the middle in both of those. So triangle ABC is congruent to triangle DEF because of side angle side. Evidence, conclusion. All right, for the final part of this lesson, we're going to show that if two triangles are congruent, there are a set of rigid transformations that will map them onto each other. All right, so if two triangles are congruent, there is a sequence of transformations that will map them onto each other. And that makes sense, right? If these two triangles are congruent, they should fit right on top of each other. And if they fit right on top of each other, we should be able to write the transformation that would make that happen. Okay? So first thing we're going to do is prove that ABC is congruent to DEF. All right? And we're going to do that just the way we just did. We're going to collect our evidence. We see that AB is congruent to ED. Let's write that out. AB is congruent to ED. All right. We see that BC is congruent to EF. So BC is congruent to EF. And we see that AC is congruent to FD. AC is congruent to FD. All right. Well, now that I have my evidence, I'm going to write my conclusion here. So I know that triangle ABC is congruent to triangle that's the wrong angle, D, remember because A and D have to correspond, D, E, F, because of side angle side congruence. Okay? So I know that they're now congruent, so there should be a sequence of transformations that map them onto each other. Well, this is all from Unit 1. You're just going to recall these skills. How are we going to get these to map onto each other? The first thing we should probably do is do a translation. All right? So we draw a line. Let's map them next to each other. We draw a line. I want to map B onto E. So the first thing we're going to do is a translation along BE. You might remember that you have to write the line that you're translating across. So if we go from B to E, well, sure enough, they map onto each other, right? Then the next thing we could do is a reflection. So let's reflect them over each other. So, and then a reflection. And you always have to put the line of symmetry, right? So our line of symmetry is down here. All right, this is our line of symmetry. It's what cuts in the middle. And that's what we're going to reflect it over. So we're going to reflect it over EF. And that maps triangle ABC onto triangle DEF. Man, I'm running out of room here. All right? So if two triangles are congruent, then there is a series of rigid transformations that map them onto each other every time. If they are the same size, there should be a way to get them on top of each other. All right, let's try it one more time. Prove the following triangles are congruent, then describe a sequence of transformations that maps them onto each other. All right, we'll start with the proof. Now what I'd like you to do is do the proving part yourself. I'm going to pause the video and see if you can do it yourself. I'll put the answer in. Pause it now. Okay, we got DG is congruent to CT, angle G is congruent to angle T, and GO is congruent to AT. It doesn't matter the order that that's in as long as you wrote those three things. And that means that triangle DOG is congruent to triangle CAT because of side angle side congruence. Alright, that proves that those two are congruent. And that's definitely side angle side. Two sides, angle in between. Now we have to describe a sequence of transformations that map DOG to CAT. Now what you want to do is map the angles that are congruent onto each other. Okay, not the random ones, but the angles that are congruent. So first let's start with the translation. Alright, we're going to map the two angles that are congruent onto each other. So let's map G to T. Okay? So first we're going to do a translation along GT. That's our first thing. We're mapping the congruent angles onto each other. Alright? So, oh, that's not good. Let's move this whole shebang with us. Alright. It comes down and it goes over here. Okay. Now the next part is we have to rotate this. Alright. So this has to rotate to get on top of each other. Ugh, that looks ugly. But we're going to rotate this now. So this is, and then a rotation. And you don't have to put the degrees now. Just a rotation around point G. Alright? So if I rotate this around point G until AT and if I rotate this like that, so AT and DG line up, then they are mapped on top of each other. So a translation along GT and then a rotation around point G in counterclockwise. And that shows that they can be on top of each other. Alright, that's it for this lesson. It's a long one, but a goodie. Yeah, go take a nap.